Welcome to 2.5. This is page 4. Let's go ahead and find a polynomial function with real coefficients. In other words, my final answer cannot have i's as a part of it. Polynomial function with real coefficients that has the given zeros. There are many correct answers. We'll talk about that and address that even further in 52 and 54. So, if -3 is a 0, then x minus -3 or x plus 3 is a factor. -3 is a second 0. X plus 3 is another factor. And I is a 0. X minus I is a factor. Now, you may remember this rule is that complex, from our note page, complex zeros occur in conjugate pairs. And this 0, I, is 0 plus I. That occurs in conjugate pairs, so the conjugate of that is 0 minus I, so negative I must also be a 0. And that's critical for this. So x minus negative I, x plus I is a 0. And there's a polynomial function. So in some ways we have this question answered. Find a polynomial function with real coefficients. Well, I found a polynomial function. And then what about this? There are many correct answers. Well, these would still be zeros no matter what number was put here in front. So provided that number is not 0. So any non-zero A gives exactly just these 4 zeros. So we'll just say A is 1 for simplicity's sakes. But now we need to superfoil this out, because good things are going to happen with this imaginary. We're not allowed to find a polynomial function with real coefficients. We're not allowed to have imaginary parts to it. So let's go ahead and foil this. X plus 3 times x plus 3, we get x squared plus 3x plus 3x. And 3 times 3, 9. When we foil this, the conjugate works really well for us. We get x squared, we get plus xi, but minus xi, and that's the magic. And then we get minus I squared, but that becomes x squared minus -1, x squared plus 1. And now I'm going to FOIL that out. In some regards, we actually have a good answer right here, but we're going to go ahead and put this in standard polynomial form, which we would normally do. We'd normally either be entirely factored or standard polynomial form. So I could take x squared times each of these, and 6x times each of these, and 9 times each of these, but some of those might combine. So here's what I do. The biggest exponent I'm going to get on x is to the 4th, and this is the only place I'm going to get to the 4ths. So that is just x squared times x squared, x to the 4th. And now I go searching for x cubes, and I can't get an x cubed going x squared times one of these, but 6x times x squared gives me 1. There's an x cubed, so that's 6x cubes. Can't get one with a 9, and can't get one other than that 6x cubed coming back. So plus 6x cubes. How about x squareds? I get one of them here and 9 more of them there. Plus 10x squareds. How about just plain x's? 6x times 1 is the only place I get plain old x's, plus 6x, and 9 times 1 non-x's. Okay, so there we've got it. Now, complex zeros occur in conjugate pairs. Complex zeros occur in conjugate pairs, so 1 minus square root of 2i is a 0 as well. So here we have f of x equals x minus 0, or just x minus 4 x minus this, distribute the negative, distribute the minus, x minus this would be x minus 1 minus square root of 2I, and x minus this one would be x minus 1 plus square root of 2I when I distribute that negative. Kind of writing uphill here. Okay, let's distribute this, and again there could be an a in front of here, some non-zero number multiplied, and we get the same zeros. So let's distribute this. We get x squared minus 4x. And now let's go through the process distributing here. The only place I'm going to get an x squared is x times x. Now, where can I get plain old numeric x's, not with the i's? I get minus an x, and I get minus an x here. See it? Minus an x, minus 2x. Now let's continue with the x's. Where do I get complex x's? All the way out here. I get x squared of 2I, but I get minus x squared of 2I, and that's the conjugate going to work for us. So I'm done with the x's. So how about just a plain old number? I get minus 1 times minus 1 plus 1. How about the numbers mixed with the imaginaries? Watch this one. Here's minus square root of 2I, and here's plus square root of 2I. Those cancel. So I'm done with the ones, and all I'm left with is the imaginary times the imaginary. Minus times plus minus, square root of 2 times square root of 2, 2. I times I squared. So that is x squared minus 4x, x squared minus 2x. I squared, of course, is negative 1. Negative 1 times minus 2 is plus 2. I've got 1 plus 2 plus 3. Now again, you could, if you wanted to, you could go ahead when you FOIL this thing and take x times each of these, 3, write it down, negative 1 times each of these, write it down, negative square root of 2I times each of these, write it down. Then you'd have 9 terms, but it would simplify to end up being this. Okay, the biggest exponent I'm going to get is x to the 4th. And it's just x squared times x squared. How about x cubes? Here we go. There's minus 2x cubes minus 4x cubes. So minus 2 minus 4 minus 6 x cubes. How about x squareds? Where can I get x squareds? I've got x squared times 3. There's 3 of them. And I've got, I can't get an x squared here, but can here. I get 8 of them here. 3 of them, 8 of them, for 11 x squareds. Next, how about plain old x's? The only place I can get plain old x's looks to be here. Minus 4x, negative 4x times 3, negative 12x, or minus 12x. Okay, and there we have it. And we're going to do something very similar, but take it just a little bit further here. In 51 through 54, a polynomial function f with real coefficients has given degree, zeros, and a solution point. Write the function in completely factored form and in polynomial form. So here we go. 4th degree f of x equals, if 1 is a 0, I left a space here on purpose, x minus 1 is a factor. If negative 4 is a 0, x minus negative 4 or x plus 4 is a factor. If square root of 3 times I is a 0, x minus square root of 3 times I is a factor, but conjugate zeros occur, or excuse me, complex zeros occur in conjugate pairs. So 0 minus square root of 3i must be a 0, making x minus negative or plus square root of 3i. a factor. And now the a out in front of here is going to matter because of this solution point. And we'll talk about that shortly. So right now, I need to figure out what a is going to be, but the first thing I'm going to do here is I'm going to go ahead and I'm going to FOIL all this out other than the a. F of x equals a times, let's FOIL this, I get x squared plus 4x minus 1x plus 3x minus 1 times 4 minus 4. And let's FOIL this out, which is kind of nice because it's pretty simple conjugate. We get x squared. I get minus x squared of 3i, but I get plus square root of 3 times x times I, but I get minus square root of 3 times x times I. So those cancel, and finally I get minus times plus minus, square root of 3 times square root of 3, 3, I times I squared, but I squared is negative 1, making this plus. Okay, and then I get f of x. I'm not going to distribute the a, you'll see why. The biggest exponent I'm going to get here is x to the 4th, and this is the only place I can get an x to the 4th. How about x cubes? Can't get, oh yeah, there they are. 3x cubes this way, and that's the only place I can get x cubes. Plus 3x cubed. How about x squareds? There's 3 here and minus 4 there. 3 minus 4 minus 1x squared. And how about plain old x's? 3x times 3 and plain old numbers, minus 12. Okay, now here's where the solution point comes in. See, we don't know what value of a is. We've got a graph that has these zeros, but again, if a happens to be 15, and I put 15 here, we still have all the same zeros. We have to ensure that a is a value that makes our graph tall enough that it passes through the point 0, negative 6. So I want f of 0, I want f to be negative 6 when x is 0. So that's a times 0 to the 4th plus 3 times 0 cubed minus 0 squared plus 9 times 0 minus 12. And having that be 0 makes my work a lot easier here. So this is negative 6 equals a times negative 12. Therefore, a is 1/2. So my final solution up here, let's see, completely factored form, so I'll call this answer a, is just replace this with 1/2. And then in polynomial form, I just have to distribute 1/2 through to these. So f of x b is, if a was 1/2, I would get 1/2 x to the 4th plus 3/2 x cubed minus 1/2 x squared, plus distribute that 1/2 here, 9/2 x, distribute the 1/2 here, minus 6. Sneaky. And as you can see, we don't want to write too large on that one. Okay. 54. This is going to end up being my A answer if I follow the same pattern as I did in 52. F of x equals something times x minus negative 2, x plus 2, times x minus this 0. If this is a 0, then x minus it would be minus 2 square root of 2i. But so would its conjugate. So that's x minus 2 plus, distribute the minus, plus 2 square root of 2i. And we got some foiling to do, and eventually I'm going to put an answer there, whatever a ends up being. So let's see, f of x equals something times, I've just got a plain old x plus 2. I would not want to FOIL this to here. It's just going to create a big mess. I want to work with these first because I've got a conjugate that's going to go to work for me. So let's let that conjugate go to work. The only place I'm going to get an x squared is here. X's and the real values, minus 2x and minus 2x, minus 4x. X's in the imaginary, here we go, 2 times x, so 2x square root of 2i, but look at this, minus 2x square root of 2i cancels. That's nice, done with the x's. The real part times the real part, minus 2 plus 4. The real and the imaginary, minus 4 square root of 2i, but plus 4 square root of 2i. That little conjugate's really helpful here. And finally, the mess with the mess. Minus times minus, minus. 2 times 2, 4. Square root of 2 times square root of 2, 2. I times I squared. So f of x equals, I'll call it a now, a times x plus 2 times x squared minus 4x. This I squared is negative 1, making this plus 8, plus 4 plus 8 plus 12. And FOIL. You're getting your foiling practices and super foiling practice on this assignment. I don't know why I did that. Sorry about that. Space is of a premium too. I get a times, I guess I could have gotten away with some of that. The only place I'm going to get an x cubed is right here. X cubed. How about x squareds? Minus 4 of them, but plus 2 of them. Minus 4 plus 2 minus 2x squared. Plain old x's, I can get 12 on the outsides. 12, but minus 8. 12 minus 8. 4 x's. Plain old numbers, 2 times 12 plus 24. And now, a little bit rougher than the last one, they tell us when we put negative 1 in for x, we end up with negative 34. I need negative 1 cubed minus 2 times negative 1 squared plus 4 times negative 1 plus 24. Or negative 34 equals a times, that would be negative 1. Negative 1 cubed, negative 1. Negative 1 squared is positive 1 times negative 2 minus 2. 4 times minus 1. 4 times negative 1 is minus 4 plus 24. So negative 34 equals a times, let's see, 24 minus 7. Negative 1, negative 2, negative 3, negative 7. 24 minus 7, 17. Therefore, a is negative 2 when we divide 17. So negative 2, there's my a answer. And my b answer is distribute negative 2 through this. So I get f of x equals negative 2x cubed. Negative 2 times negative 2 plus 4x squared. Negative 2 times 4x minus 8x. Negative 2 times 24 minus 48. Great foiling practice. There's a 20-minute video. Might take you maybe a little bit less time than that without the explanation. Ask questions when you have them. Good luck.